Hello, my name is Thomas Rodriguez, and I will be going over Lab 3 for Physics 2211. So to introduce this lab, it involves two parts that relate to each other. Part 1 is calculating the mass of a black hole with a star orbiting around it, and Part 2 is calculating all the forces on a spaceship traveling around a planet orbiting a black hole. And then when the spaceship stops working, we're tasked with figuring out the initial velocity required for the spaceship not to crash on the planet nor the black hole. And then the fundamental physics principles. One is the Newton's second law, which is that the net force is equal to the rate of change in momentum. And then there's also net force is equal to force parallel plus force perpendicular. Then there's also gravitational force, which is this equation, which you use in both Part 1 and Part 2 to solve for the gravitational forces involved in the systems. And then there's the position update formula and velocity update formula to solve for the paths of the spaceship and the planet in Part 2. In Part 1, using the gravitational force formula, you can find the mass of the black hole. And for Part 2, I was able to get the spaceship to not crash by calculating the initial velocity required for that to happen. And then for an overview of the lab, for Part 1, it involves a star's orbit around a black hole. And for Part 2, it involves two things: a spaceship's path around a black hole, and also a planet's orbit around the black hole. And for the initial conditions, it's the gravitational constant and the mass of the star in Part 1 and the delta T, which are given in the lab instructions. For Part 1, the system is the star and the surroundings is the gravitational force from the black hole. Then for Part 2, the system is the spaceship and the surroundings is the gravitational force from the black hole on the spaceship and the gravitational force from the planet on the spaceship. For Part 1, I plugged in the mass of the star and the change in time. And as you can see from the code here, I probably won't explain all of it, but I'll explain like the gist. So for here, for example, I use Newton's second law, so like F net is equal to the change in momentum. Then also here I calculate the net force in the parallel direction and the net force in the perpendicular direction. And then using all of these values here, I was able to calculate for the mass of the black hole using the gravitational force formula. And then this is just the code for the arrows for the model, or like the visualization. And then this is the model for Part 1. So it's just the star orbiting around the black hole, and then this is the arrow pointing toward the black hole. So when you run the program, through every iteration, a mass of the black hole will pop up, and then you just solve for the average of all of those masses to get the estimated value for the mass of the black hole. And then for Part 2, this is where I solve for the initial velocity, which I did through trial and error. And then here in this code, it's just solving for things like displacement and like using the gravitational force. And then here is the velocity update formula and position update formula. And this is what is created from the code. So the purple path is the path of the spaceship and the blue path is the path of the planet. And I don't know if there's really much to say about the similarities and differences between them, but I guess like the star orbiting around the planet, around the black hole, and the planet orbiting around the black hole are both circular, but then the path of the spaceship is not circular and it's escaping from the event horizon of the black hole. So for possible errors, is that the calculated mass of the black hole and the values for initial velocity, which were given through trial and error, are not perfect estimations. For the what does it mean question, the difference between the net force and the rate of change in momentum, They're technically the same value because of the this formula, but the way that you calculate them is different. So momentum is easier to solve, while Fnet is harder because of the amount of work that it takes. And then for the what if question, I solved it through trial and error, and I was able to get this visualization for what initial velocity would the spaceship need to enter into that kind of orbit. And that concludes my presentation. Thank you.